Okay, let's look at this. Basically, we're going to just do a series of processes, right? There's a isobaric process, isochoric. This one is isothermal. This one is adiabatic. Okay, but the first one here is we're going to do this is the isobaric process, right? Okay. So they tell you that point X is at 100 kelvins. Now, they don't have to tell you that, by the way. They don't have to tell you what the temperature is or even the moles. We can actually solve a lot of this stuff without that, right? But anyway, let's go. They tell us it's 100 kelvins. So how many moles of gas do we have? And the number of moles, we're just going to use the ideal gas law, right? So PV is nRT. So therefore, T is equal to, what is it? PV, we're solving for N. N is equal to PV over RT, right? So that's going to be, and then this is, notice that this is times 10 to the 5th, right? So that's going to be 8 E5. Our volume, notice that that's times 10 to the minus 3rd, right? So that's 2E minus 3. Those are liters, by the way. Thousandths of a cubic meter are liters, right? And then we're going to divide by R, which is 8.31, and our temperature is 100, right? Okay, so let's just try that. I'm actually going to use the fraction key on my calculator. All right, so 8 E5 times 2 E minus 3 over 8.31 times 100. And I get that the number of moles is 1.9254 moles, approximately, right? Okay. So what is the temperature at point A? And again, I could use by the way, I could use the ideal gas law. If you panic, don't we know the pressure is 8 times 10 to the 3rd, the volume is 6 times 10 to the minus 3rd. Now we know N, we know R, we could solve for T. But there's a much simpler way to do this, right? Notice that we start at 2 and we go to 6, right? So the volume is times 3, right? So therefore the temperature is going to be times 3, right? And so the temperature is going to be 3 times 100. It's going to be 300 kelvins, right? So if I write this down, this is 100 kelvins. And then if we go 1 times 2 times 3, right, that's going to be 300 kelvins, right? Okay, so that's our temperature, right? And then for that isobaric process, let's find Q, delta U, and W. Now remember that Q is equal to delta U plus W. So we're not going to find Q first. We're going to find these guys first and then add them up to get this, right? So let's find the work. Right, the work is pressure change in volume, right? So that's 8E3 or 8E5, right? Because notice it's 8 times 10 to the 5th, right? Times, and our change in volume is, let's see, 1, 2, 3, 4. And then that is going to be 8E5 times 4 E minus 3, that's 3,200 joules of work, right? And now let's figure out the change in internal energy, right? Okay, so the change in internal energy, properly, now by the way, the only formula we officially have is that we can go, the change is 3/2 NR change in temperature, right? Okay, so let's go ahead and do that, but I'll show you a shortcut. Okay, but this is the official way we're supposed to do it, which of course requires that we know the moles, right? Okay, so let's see, it's going to be 3/2 times, and I'll use that unrounded value, so 1.9254 times 8.31, and then our temperature went from 100 to 300, so the change in temperature is 200, right? So 3 divided by 2 times that number of moles that I got, I'm just going to grab the entire thing, all of those digits, right? Times 8.31 times 200 is 4,800. Now that seems like a strangely round number, right? Okay, what's the other way to get it? Well, this is it, right? This is the way to do it. It's actually 3/2 P delta V, okay? Why does that work? Well, because PV equals nRT, right? Okay, so we can just substitute. Anytime you see nRT, right, you can do PV. So let's try that. 3/2 times 8E5 times 4E minus 3, right? And this is our PV. I'm just looking at that, right? So basically 3 divided by 2 times 3200, right, is 4800. Right? And now we're ready. Now we can figure out our Q, right? Q is delta U, which is 4800 plus work, right? Anybody can see that's 8,000 joules, right? Ta-da. Okay, so we've got, this is our work. This is our change in internal energy. This is the way to calculate it, right? This does not require us to do this whole fancy, complicated thing. We can just do this, okay? Anyway, that's what you do with isobaric processes, okay?